So we're now going to be looking at exponential models and regression. We're going to start by looking at a linear model and linking that with regression just to refresh our memories about how that works. So the example we've got here is the table shows the daily maximum relative humidity H% and the daily mean visibility V decameters dm in Heathrow for the first 2 weeks in September 2015 from the large data set. So this is for Edexcel. So you've got a table there that's giving some information about humidity and visibility. So it's just a table with some numbers in. And we are told that the equation of the regression line of V on H is V equals 12,700 subtract 106H. The first question is asking us to give an interpretation of the value of the gradient of the regression line. So if you think back to what you know about gradient from when you were first learning about it, it was on change in y over change in x. And the other thing that you might have thought about is the fact that gradient is telling you what y changes by when x increases by 1. And so that's kind of what's going on here. So the gradient of this regression line is minus 106. And so what that is telling us is that as the humidity increases by 1%, the visibility is decreasing by 106 decameters. So question B is about our knowledge of the large data set. We need to explain whether there is likely to be a causal relationship between humidity and visibility. I would say yes in this case. So causal relationship means that if you increase the humidity, that causes the visibility to, in this case, decrease. And that would make sense because high humidity, i.e. over 95%, is associated with mist and fog. So that's something that you need to know from the large data set. In fact, that little fact. And so that suggests that as humidity increases, you would expect the visibility to decrease. And we need to think about question C here. So given reasons why it would be not reliable to use the equation to predict, and then two things. First of all, the mean visibility on a day with 100% humidity. So the data we have, the humidity only goes up to 98%. So 100% humidity is outside the range of the data, and therefore we would not get a reliable estimate. Second part of it, we can't use it to predict humidity on a day with visibility of 3,000 decameters because we have the equation of the regression line of V on H. If we were trying to predict the humidity from the visibility, we need the regression line of H on V, so therefore it's not reliable. And final question on this. State 2 ways in which better use could be made of a large data set to produce a model describing the relationship between humidity and visibility. Sort of default go-to answer on these kind of things is to say take a larger sample, and possibly you could do that, but two more detailed reasons that would be really actually showing your knowledge of the large data set rather than just giving a general kind of answer would be that we could pick days from a wider range of times in the year. So the data we had is just from September, and so it would make sense if we took data from across the whole range of the months that were within the large data set, and it's only been taken from one location. So to improve the model, we perhaps ought to be taking data from different locations within the large data set.